we're going to be looking here at the angle bisector for today. Now, the angle bisector basically says there is a line that crosses an angle here or intersects it exactly halfway. Basically, it is saying, look, if I grab the angle ABC, and I use this line here to cut it exactly in half, then it's saying that angle 1 and angle 2 will be exactly the same. So I can write this as angle ABC should be the same if I add angle 1 plus angle 2. However, because this is cut exactly in half, I can also say that ABC, the angle ABC, the whole piece, is the same if I just double angle 1. Because angle 1 is exactly half of the entire piece. And same thing, if I want to talk about angle 2, it is the same. I can just double the size of angle 2 and it will give me the entire measurement. So just as an easy understanding here, if this angle ABC, so if ABC is 100 degrees, and if I have an angle bisector that cuts it in half, then this angle here will have to be 50 degrees, and this one has to be 50 degrees. They have to be exactly half of the entire angle. It cannot be 40 and 60. It is not just a random line being drawn. It is a line that cuts it exactly in half. So even if you do have like a decimal, let's say for instance 50.5, then this would be 25.25, and this would also be 25.25. So just be aware of that. So let's look at our examples now. We're going to go through a couple of them here. So in this case here, it says, look, the angle SQR, they want us to find this. Okay, so they want us to find the entire piece here. And they're telling us, that angle 1 is 25 degrees. So this piece here is 25 degrees. But because we are dealing with the angle bisector, well, if this is 25, then this piece here is also 25. Then therefore, the angle of SQR, or the measurement, which is what the M represents in front, is going to be 50 degrees. Let's look at the one here in the bottom. Actually, no, let's look at the one on the right side, number 2. Number 2 is using the exact same letters, SQR this time. The entire piece is 34. And they're asking us to find angle 2. Now, angle 2 and angle 1 have the exact same measurement because this is an angle bisector here. Therefore, all I have to do with the 34 here is just split it in half, divided by 2. And if I divide this by 2, then each one will have its own measurement, equal measurements, which will just be 17 degrees. So angle 2 is 17 degrees. So that's example 1. Example 2, let's look at example number 5 over here. Now we're going to be looking at problems that require us to look for the value of x, but not necessarily go back to plug it in to find an exact angle. So we're just looking for x. Now in this one here, they tell us angle 2 is 2x plus 14. So that's this one here. And they're telling us SQR, which is the entire angle here, is 8x minus 4. It is always easier to write your equals portion, if you know what the larger piece is, to set it to the right side. I have 2 choices when I can try to solve this one. Since I already have angle 2, and I know this is exactly half of this, what I could say is, I can say, well, if I add angle 1 and angle 2, it is the entire piece. Or, since they only gave me angle 2, I can just double its value and it will equal the larger piece. So that's what I'm going to do on this one. So in this case here, I'm going to double angle 2, which is 2x plus 14. I'm going to multiply everything by 2. So make sure you distribute correctly. So 2 goes multiplied by 2, and 2 also multiplies to that 14. So here we get 4x plus 28 equals 8x minus 4. Now we just start doing the orders of operation. In this case, I'm going to subtract 4x to both sides. It's usually easier to subtract a smaller x. And then I'm going to add 4 to the other side here. Add 4, add 4. So 8 minus 4 is going to give us 4x. 28 plus 4 is 32. I then divide by 4. And I'm going to get that x equals 8. And there's my solution for this one. Now, if I look at number 8 here, the last one, this one's a little trickier. Now, on this case here, I have 3x plus 7. That's angle 1. And on this one, for angle 2, I have 4x minus 3. Now, you might be thinking, well, I just need to solve for x, and if I add this one and this one, they give me the entire piece, but the issue is we don't have the entire piece. But the main thing to remember is that angle 1 and angle 2 were created by this bisector here. So they have to be equal to each other. Therefore, I can just set angle 1 to be equal to angle 2. So I can say 3x plus 7 equals 4x minus 3. I'm going to subtract the 3x to get rid of this part. I'm going to move the minus 3 to the left side. We want to have variables on one side and then the constant values on the other. 3's are going to go away. 4 minus 3 gives us 1x. 7 plus 3 gives us 10. So x equals 10. And that's all we have to do on these. We just have to solve for x. So we have 4 different examples here. The first 2 just deal with the numerical values. Example number 5 over here deals with what if they only give you one of the inside and they give you the larger piece. And the last example here is what happens when they give you both of the insides but not the outside. We set them equal to each other. Make sure you